Good morning and good evening, everyone who's calling in from the United States or Southeast Asia. We're very happy that you can join us for this evening's event, Where's the Water? Mekong Dry Season 2025. We're going to give everyone a minute to come in from the waiting room before we get started, so please hang tight and we'll begin very shortly. I see we're still getting people trickling in. All right, I think we've got a lot of the folks who are in the waiting room on the line now. So thank you all for joining us and welcome to the seasonal update, Where's the Water? Mekong Dry Season 2025. We might still have a few folks joining us, but in the interest of time, we'll go ahead and get started. For those who I don't know yet, my name is Courtney Weatherby, and I'm the Deputy Director for our Southeast Asia program and a fellow with the Energy, Water, and Sustainability program here at the Simpson Center, and I support our team on the Mekong Dam Monitor. As many of you calling in know, our team at the Simpson Center, in collaboration with many friends and colleagues in the United States and across the Mekong region, work together to use satellite data, remote sensing, and on-the-ground data from gauges run by the Mekong River Commission and reporting from local dam operators to track how dams affect the Mekong River's flow and the health of the Mekong River system. We currently monitor about 16 dams in the basin on a near real-time basis with weekly updates. And we put out a series of additional and targeted analysis and references to help stakeholders understand and see what is going on, not just on a weekly basis, but also looking at some of the broader trends. So this event is one in a series of our seasonal briefings to share updates and comments from our team as well as outside experts. This year, for those who are not on our mailing list, has been an eventful one. We've just very recently published two new reports. Our annual report for 2023 to 2024, which overviews key lessons learned in this past year and analysis in terms of what has been going on with the river system and dam operations and what it means for the future of the Mekong. We also just recently published our annual progress report, 2024, which really digs into sort of best practices and what are some of the future plans and activities for the Mekong Dam Monitor and our partners. So my colleagues will really get into the details of our insights on this call today, but one key takeaway from our annual report is that changing climate conditions translate to undesirable outcomes for dam operators in some years, and in some cases can turn into more desirable outcomes for communities across the Mekong Basin during the dry season as compared to other years in recent history. And it identifies opportunities for improved data sharing between governments, dam operators, and communities, which could lead to a more sophisticated approach to dam operations to conserve key conditions for the river and also key ecological features like the annual flood pulse and the expansion of the Tonle Sap Lake. So I'm happy to share those links in the chat with everyone very shortly. But with that in mind, I do want to welcome everyone to tune in for the meat of our discussion tonight with the Mekong Dam Monitor co-leads, Brian Eiler and Alan Basiste, about how dams and climate have affected the river system over the previous wet season, particularly through extreme events, which have highlighted the need for improved early warning and forecasting, as well as to get a bit of an overview of what we expect to see this dry season. And today we're also delighted to welcome some additional insights from two outside colleagues, Dr. Zeb Hogan and Srelak Mek, to contribute insights from their own work on the ground to help explore what the current status of things are in the Mekong. So with that said, I'm going to go ahead and prepare to turn things over to our first commentator. We're actually going to start with some insights from Zeb Hogan rather than our team, because there's some exciting news that's just come out of the Mekong. For those who don't know him, Zeb is the host of National Geographic's Monster Fish, and he's a research biologist at the University of Nevada, Reno. And he has some very exciting news to share for us about a recent catch, tag, and release of not just one, but 6 Mekong giant catfish. So Zeb, I'm going to go ahead and turn things over to you.
Thank you. Thanks, Courtney. Thank you, Brian. Thank you, Stimson, for the opportunity to join everyone. My name is Dr. Zeb Hogan. I am the project lead of the USAID-funded Wonders of the Mekong project. The Wonders of the Mekong project launched formally in 2016. We kind of broadly focus on highlighting, increasing knowledge about and highlighting the many values of a healthy Mekong River. So we focus broadly on water issues, fisheries, biodiversity. And starting in 2016, we've been working primarily in Cambodia, but recently the project was extended just this year. And so we're going to be continuing the project through 2029 and expanding activities to all 4 countries of the Lower Mekong Basin. So in addition to keeping our core team and our core activities in Cambodia, we're looking and excited to explore opportunities to expand into Thailand, Laos, and Vietnam. So today, Brian and Courtney asked me to join to share some exciting news from Cambodia last week. As Courtney mentioned, there was kind of an unexpected and unprecedented catch of a critically endangered species, one of the world's largest freshwater fish, the Mekong giant catfish. This is a species that 100 years ago was, there are records of it being caught in the thousands all throughout the Mekong Basin. And populations of this fish have dropped from hundreds of fish in the mid-1900s to dozens of fish in the 1990s. There was sort of one last remaining fishery up in northern Thailand in the Chiang Khong and Bokeo area, up in the Golden Triangle area. And so around 2000, the reported catch of this species basically dropped to very few, a number that you could count on your hand. And we've been monitoring and working on the conservation of this species since 2000, so for almost 25 years. And this catch this year was the highest catch. There were 3 fish caught on a single day. So this is kind of the highest reported catch of this species for a week-long period in the last 25 years. So pretty remarkable and unexpected and unusual. And so I guess I'd just like to put, this is just one species. It's a critically endangered species. It's an iconic species. It's symbolic of the health of the Mekong. But I guess I'd just like to quickly kind of put the catch in context, kind of what it means specifically, what it means more generally, and then talk a little bit about broader implications and what we're seeing with some of these iconic species more broadly in the Mekong. So the fact that these fish were caught, so I should mention that they were caught, but we work with communities. Wonders of the Mekong cooperates with the Fisheries Administration in Cambodia and communities. When the fish are caught, incidentally, there are no targeted fisheries for this fish. It's illegal to catch them. So when they're caught incidentally, we work with the communities to tag and release these fish to learn about their ecology and migrations. And so through this tagging program, we've tagged over the course of 25 years, probably 100 of these fish, approximately 100 of these fish. And the tagging of these fish gives us an idea of the ecology and migration patterns. And so what we see from this unprecedented catch, tag, and release of fish this year is kind of for the first time we saw evidence of a group of these large fish. These are fish that can grow up to 300 kilograms. So these are big fish. So we saw evidence of a school of these giant fish migrating across Cambodia. So from the inundated areas of the Tonle Sap Lake and Tonle Sap River out into the Mekong and up into the Mekong. These fish were tagged and released in Kampong Cham, but presumably they're continuing their migration probably up into Krache, Stung Treng, to the deep pools in that area, and maybe beyond into Laos and Thailand. The only known spawning area for this species is in far north Thailand and Laos, so quite a ways from where they were caught and tagged last week. So we also see the last week we saw both juveniles and adults. So that means we're seeing all life history stages of the fish. That's a good sign. That means that they're probably still spawning somewhere. And we see the fish responding to the natural flood pulse, the natural seasonal cycles of the river. So these are fish that move out of flooded areas at the end of the rainy season and up the Mekong. And this is a cycle that we've seen historically. So these fish are still behaving in a natural way, which is a good sign with all of the pressures and impacts that we're seeing on the Mekong recently. Now, keep in mind, this is just in Cambodia. As we start to talk about further upstream, the impacts become, by some metrics, more severe. So it's unclear. We're not seeing these catches in other countries at the moment. So keep in mind that this is what we're seeing in Cambodia. Sort of a deeper reason why all of these fish were reported this year is that we've been working with a long time with the communities up and down the Mekong River and conducting outreach and community. We partnered with communities to study these fish and this migration. And so I think there's a very broad awareness that when these fish are caught incidentally, that the communities know to contact us and the Fisheries Administration so that we can get involved. So I think part of the reason we're seeing an increase in the number of reports, there may have been something happening unusual this year, but it's also an increased awareness that's leading to these increased number of reports. Another aspect that I think is important to emphasize is that the Tonle Sap Lake River and the Mekong River is still a free-flowing river. And so this is an important migration corridor, not only for Mekong giant catfish, but for over 100 other species of fish. So the fact that we still have that free-flowing connection between the floodplain of the Tonle Sap and the deep pools of the upper Cambodian Mekong is very important. And so I guess I'd just sum up by saying that this was just one this is just one example of some of the exciting discoveries that have been made recently, especially in Cambodia. There was also the rediscovery of a presumed extinct giant fish species called the giant salmon carp that was recently rediscovered in Cambodia. It's mainly a species that's known from Laos and Thailand, but was recently rediscovered in Cambodia. And then also the Wonders of the Mekong project, working with our partners and communities in northern Cambodia, was able to tag and release the world's largest freshwater fish, which is a freshwater stingray, recently, and able to follow that fish and learn about its ecology and migration as well. So there's actually a lot of exciting aquatic biodiversity news that's been coming from Cambodia, the Cambodian Mekong recently. And this recent unprecedented catch of Mekong giant catfish is another example of, or highlights that the fact that the Mekong River is still incredibly important to people living along the river, incredibly important for livelihoods, food security, and biodiversity. So I think with that, I'll end it, and then I'm happy to join the discussion later on or answer questions. Thank you.
Thank you so much for that, Zeb. I think it's always heartening to see specific stories like this that point at the situation in the region, but I personally find it very inspiring to see that this is the fruit of improved collaboration and awareness raising in local communities along the river. I think citizen science and collaboration between local communities, researchers, CSOs, and government is one of the bright spots that we can sometimes see progress in. So with that in mind, I'm going to go ahead and turn things over for really sort of the research and insight portion of this discussion to Brian Eiler, who's the director of our Southeast Asia program and the Energy, Water, and Sustainability program here at the Simpson Center, as well as Alan Basiste, who's the president and founder of Eyes on Earth. As many of you probably know already, they co-lead the Mekong Dam Monitor, and they are going to give you the seasonal update on what we've learned from this past wet season and what we have to look forward to. So, Brian, with that, I will turn things over to you.
Thank you, Courtney, and thank you, Zeb. Thank you, Zeb, for going through this, what I've called the big fish story of the century for the Mekong online. And it was just great to see this story get out over the weekend. I was at home in my hometown in central Pennsylvania over the weekend, and the AP story done by Aniruddha Gosal hit my local hometown newspaper. My mother showed it to me on her iPad. So, if it's getting to small town newspapers in Pennsylvania, it's really getting out. And again, kudos to you and the team for making this story happen. Alan Basiste is joining us here. Alan, where are you calling in from?
I'm in Phuket, Cambodia now, and visiting basically Vietnam and Cambodia and getting a chance to spend a block of time engaged in the community.
That's great. What do you see around you? What's unique about Persat?
Well, it's a very lively town. The river is up. The Phuket River, Stung Phuket, is quite high right now from the end of the rainy season. And I was up in the Cardamom Mountains, and it's always good to experience something firsthand. One is to observe it by satellites, another observe it from remotely from people telling me. But I got to go up into the mountains, and I've been noticing for the last several months that it's been extremely wet up there, abnormally wet. And so I was joining a party, about 400 Cambodians celebrating a big family event, and they invited me to join them and went up to the mountains, and it rained every day. So our wetness product is tuning in with the realities that people are experiencing on the ground and in the mountains.
Indeed, and we're going to jump into that wetness product. I do have to give everyone a warning here, including regarding Zeb. Um, I was with Zeb in Bangkok last week for on Wednesday for a day. We're both back in the U.S. now. Alan and I were in Hanoi for 10 days, leading a workshop. Alan's not jet lagged, but Zeb and I are. So Alan, you're going to have to carry us here with some good Mekong energy. Why don't you lead us through what we've seen happen over the last wet season of 2024, and then we'll move into what we think is going to happen potentially here in the coming dry season in 2025. It's hard to believe, 2025, right?
Yeah, we've moving through the years. It's amazing how quickly they're adding up. We've been monitoring the Mekong now for 4 years, and we're watching changes that are happening. And it's nice to hear Zeb talking about some positive results that are coming out of the work and the collaborations that are working throughout Cambodia and along the Mekong Basin. If we go to temperatures, the first thing you can see is there's a lot more brown and red than there is blue or green. And that means that temperatures have generally been warmer than average throughout the entire wet season. Obviously, August stands out as and September is extreme anomalies, particularly in the upper basin where you see that temperatures were much above average. And one of the things that I'd like to note is that they're staying above average through October, November, and December. We had the most recent week in December, just processed it last week, and you see extremely warm temperatures in northern northeast Thailand and Laos, but going all the way up into the upper basin where it normally would be snow covered and snow would be accumulating in the headwaters and in the mountains and the Tibetan Plateau, but that's not happening this year. What's happening now is it's extremely wet. Our wetness product is literally just that. How wet is it? And if it's not snow covered, it's liquid, then we see it as liquid water. We see it as flowing. Instead of accumulating in a snowpack, it's flowing down through the upper basin and down towards the gauge at Chen Chen, where we're seeing basically a lot of water and flowing from the upper basin down into the lower basin. This is supposed to be the beginning of the dry season and the accumulation of snowpack, but that's not happening. So you look at all these, let's start in May very quickly and just see that red is showing below average wetness. And we're seeing it in northeast Thailand. Look at that persistence in May and June and July and into August and September and October and November. I mean, northeast Thailand, and it's been extremely dry this wet season. In contrast, you can see that there's a huge amount of wetness around the Golden Triangle, particularly in August, but even more pronounced in September. That was related to some severe floods that were happening at the Golden Triangle. And then Yagi, who came through in September, just created a huge downpour of extreme wetness into the region. And that, of course, it flowed down into the Mekong and into the Delta. As a result, you're seeing that the Delta was actually had above average wetness, throughout from July all the way through, with and still in above average wetness in the Vietnam Delta in December. So there's been a lot of water coming from the upper basin, and the floods that were pronounced in August and September are still keeping the Tonle Sap Lake, high. There's been a huge reversal, which we'll go into in a little bit. One thing that I'd like to add on this image is that we've seen what we call a dipole. We've seen the Cardamom Mountains, and this is where I said I've been up in the mountains. I've seen the reality. They've got extreme amount of water in October, November, and even into December. North of the lake, it's been dry, but south of the lake into the mountains, they've been had an extreme amount of rainfall, much above average, and that, of course, is getting into the lake. It's flooding the southern shores of the Tonle Sap, and the flood pulse is much more pronounced on the southern shore as it is to the north, where they've been having dry conditions persistently for months on end. And we'll see a little bit more than when we go look at these flood pulse in the lower Mekong. You'll see that the flood pulse is really reflected on where they're getting the rainfall. So there's two things that drive the reversal or the flood pulse. One is the reversal, the water coming in from the Mekong. Of course, that's going to flood the entire Tonle Sap Lake. But when there's a lot of wetness to the south, there's going to be much more flood pulse to the southern part of the lake compared to the north, because that's where the floodplain is being inundated by all the rainfall. So I will stop here.
Yeah.
We have a lot to share, but I'll get back to you. Do you have a comment there, Brian?
Well, we're going to look at
add?
what that looks like. We're going to zoom in on the Tonle Sap Basin. But for me, one of the unique observations on these maps is Typhoon Yagi. Typhoon Yagi was huge for it was a major disaster for so many people, not just in the Mekong Basin, but in all of mainland Southeast Asia and Hanoi, Myanmar. But look how localized, even, it was huge, but it was so localized in that northern Thailand, Golden Triangle, southern Yunnan province area in the Mekong, even though it was such a major event. We didn't see that wetness trickle down into other parts of the basin, obviously, as that water worked its way through the system. But we'll move on, and I will advance these slides.
I will say one thing before you advance it. A comment that I'd like to share with the larger group is we are seeing a shift in the rainy season. We're seeing that the rains are less pronounced in the early part of the wet season and much more pronounced at the latter part of the rainy season. You can really see it in the upper basin in November, December, but even October. So we're getting a lot more water coming in at the end of the wet season and more dryness at the early part. So it seems like the climatology is shifting. And we've noticed that not just for this year, but the previous 2 or 3 years. So we want to see if this is indeed a new climate signal and a new climatology to the region. And water management and water resource management needs to acknowledge, or at least be concerned about, this shift and how to manage water based upon the new climatology that's present.
Well, that's right. And it's something we've observed now for a few years. So we have got a hunch, and I think it's going to take more study to actually prove that hunch. We'll come back to this as well. But looking at those severe events that happened in both, well, 2 times. There was once the August flood in and around Chiang Rai province, Chiang Khong, Chiang Sen. It was very severe. It caused former Prime Minister Thaksin of Thailand to go up to Chiang Rai, where he actually railed on China's dams for exacerbating some of the flooding there. But we were watching this as it happened, and we didn't see any bad action by China's dams in particular, or any large dams in particular. In fact, we saw some coordination happening during this event that actually translated to better coordination during the Yagi event among some dam operators to reduce the impacts of floods, or at least not engage in sudden drawdowns of the reservoirs during the flood event to make things worse. Looking at what some of our own mapping shows us from that Chiang Rai flood event in August, this was actually more severe than Yagi. So we're going to do some comparisons to Yagi's flooding in Chiang Rai. But here we can see the Ying River, a tributary of the Mekong that flows into the Mekong in south of Chiang Kong in the Golden Triangle, the Gok River that flows through Chiang Rai, the rock that flows in at the Golden Triangle. These had severe flooding, 1,500 square kilometers of inundation at the peak flooding on or around August 25th. And it created huge problems for those who were affected by it. But then just 2 weeks later, Typhoon Yagi came over Hanoi in northern Vietnam, transferred into the Mekong Basin, and just dumped an unprecedented amount of water over that system again. So you can imagine this two extreme events in 3 weeks, in a 3-week period, and the kind of challenges this creates for the people and communities that are living, underscoring a need for better early warning, more anticipatory action, guidance on what one should do during a major event like this. We found that it's kind of hard to see because the image is a bit off the slide, but the August event had about 500 square kilometers more inundation than the Yagi event. And we found that the Ying River did not flood as much during the Yagi event as it did during the August floods. Alan, feel free to pipe in here anything you observe. I know you were up in working with people in the Kok River Basin actually during that first event. Please feel free to share any observations or thoughts that people were sharing at that point.
Well, we were looking at rain gauges in conjunction with satellite observations, and the thing that became most evident was that the orientation of flow went right up the Ing River in a much more pronounced and destructive way than the rain clouds moving up the Gok River. And so even though they're very close to each other and run relatively parallel, the orientation was such that the Ing got much more extreme flooding than a river basin next to it. And that's a challenge to forecast, to those localized events. And so this is where really coordinated efforts need to be developed beforehand so that early warnings can be gotten out and mitigation strategies can be done in a very localized effect. And the advantage of having local networks to communicate this message to the people is hugely beneficial towards mitigating their impacts.
And well said. We got a call from Dr. Apisom Intralawan, a good friend of all of ours here, who might be on the call as well, during the Yagi event. And he said that his home along the Gok River had flooded, and it hadn't flooded during the August floods, and was wondering what had happened. There was a rumor going around that a dam burst in Myanmar upstream on the Gok River. We spent a lot of time looking for a dam on the Gok and couldn't find one. It's still possible that something happened. Pai Ditet from International Rivers was writing about a mine and a mine tailings dam that could have burst and exacerbated the flooding downstream. More studies need to be done. But what our maps did show was this small dam near the airport. It's an irrigation dam downstream of the city of Chiang Rai. It backed up and was unable to clear the floodwaters from Yagi. And it's possible that this dam contributed to those severe floodings that Ajahn Apisom experienced in his home and so many others in Chiang Rai, making the Yagi flood so much worse for people in Chiang Rai than the August floods, which was a more intense event. I've always wondered about this small irrigation dam in Chiang Rai province and near Chiang Rai city. And there's a movement happening in the United States now about dam removal. From what I understand, this particular dam in Chiang Rai is getting kind of old. It's the only one on the Gok River. There are communities upstream that remember fishing on the Gok and when the Gok was flush with fish. And apparently it's this dam that that's blocking the fish migration pathway and now is unable to clear the water during these extreme events. Perhaps there's an opportunity here to rethink the purpose and the use of that particular dam and maybe make the Gulf free flowing again. But moving on, I just want to show some of the maps that our team created during the Yagi event. This is Nam Ta town in Laos. There was a dam, small dam upstream of Nam Ta that overtopped, but it was not destroyed from what I understand. And you can get a feel for a small dam's inability to handle all of this water coming in over Nam Ta. For those of you with like a scale, you can see a runway on that map, and you get a feel for the large extent of flooding that happened in the town of Nam Ta, Laos. Here is Nong Khai, Thailand. We're just downstream from Vientiane, Laos on the north side of the river, and Thailand on the south side of the river. Some extreme flooding that happened there. This map is a much larger scale than the Nam Ta map. And this type of flooding would have been seen throughout the entirety of the Yagi event. One observation that struck me was we saw the Mekong River Commission and many other agencies at the national level in local language and in English forecast Typhoon Yagi 8-9 days before Yagi hit. And there was good flood forecasting as well that came out of the Mekong River Commission on Facebook and other platforms. The MRC post here on September 11th talks about the water level at Luang Prabang reaching flood level. And indeed, it did reach flood level, and it was well forecasted. But then if you look at the right side, we can see a comment from someone there in Luang Prabang saying that there's a significant gap in messaging, the message that needs to be delivered to tens of thousands or millions of people that are being affected by one of these events. The person talks about no plan, no messaging on where to go, what they should do during a severe event like this. And I thought the MRC's response was, I mean, it was genuine, but at the same time, to me, it came across as a little tone deaf and a signal of potentially where improvement and capacity could be built for anticipatory action or early warning messaging to guide people through these types of risks, where the MRC said, you know, it's basically not our mandate to provide this type of information. Please refer to your country's national disaster risk management platform for this information. Absolutely true. But again, things were revealed during this particular event. Alan, what's your take on what you're seeing here?
Well, this is where information and knowledge can be provided in a timely fashion so that actions and mitigation strategies can be put into place. How the infrastructure is and the organizational structure is defined is really a local issue. But clearly the MRC, in conjunction with the national agencies, could come together and organize the information that they have in a way that can be more effectively communicated in a warning system to help basically prepare people for how to undermine or mitigate or protect themselves from these floods in a timely fashion. So looking at what we can learn from this, what kind of organizational structure, what kind of communication could be conveyed, and how does it get out to the community level in a way that's actionable?
All right, well, let's move on and look and explore how the extreme wetness of those two events and then other precipitation over the course of the wet season affected dams. So we'll get into the meat of what we do and talk about how dams were operated during the wet season. So in the past, at our most recent webinars, we've talked about how the Nojadu Dam, the largest dam in the system, was unable to fill over many of the previous years. And the most recent wet season before this one in 2023, the dam only filled up to 50%. But look at 2024, it made it to the top. So for the first time since 2020, that reservoir hit a high number. And in fact, it hit a higher level than ever before observed in the 8 years of data that we created for the Nuojadu Dam of observational data. So the reservoir it's now releasing its water, but it was at a new high. And I think something here is quite interesting, and we'll get into it later, but there's an opportunity to rethink how dams are being operated in a way that can actually benefit the flood pulse downstream, or not have the flood pulse be as affected in a way that during the core months when it energizes, which is typically June, July, and August, the big dams are holding the water back. So what's unique about Nuojadu in China, this particular wet season, is that it filled up with more than 2 cubic kilometers or 2 billion cubic meters of water before the wet season started. So something was happening up there in China that enabled that particular condition to be met. And you can see how the dam kind of held steady with its reservoir through those core wet season months, and then waited towards the end, the later months of the wet season to fill up. Something unique happened, and it's notable and worth remarking on. 2024 compared to 2023, most of the large dams filled all the way. So Nuojadu, Xiaowan, the 2 largest dams in the system, those dams, you've got to add their active storage. Smaller dams in the system in other countries, you've got to add many of those together to equal just one Xiaowan or one Nuojadu. Those dams are huge and they have big impacts over downstream outcomes. Both of them filled to 100%. And again, it was the first time we'd seen this in a long time. And in fact, in China, this past wet season, reservoirs hit the highest levels observed since we started our work with the Mekong Dam Monitor. So 2016, 2017, the bars aren't there. Rest assured that 2018 was the highest level observed, or volume observed, of the major reservoirs in China. Now 2024, slightly higher, 23.1 cubic kilometers, or 23.1 billion cubic meters of water stored in those reservoirs, meaning that this is going to translate into something during the dry season. It's going to translate into some pretty significant releases over the course of the dry season. We'll get there in a bit. But the game changer here is that, again, Nuojadu, the yellow bar, the largest dam in the system, was able to fill all the way for the first time in a long time. And here's a place where Alan and I are going to do a little bit of back and forth, but we're beginning to think about grading performance, and shining a light on when those big dams in China and all 12 dams now operate in concert to deliver some pretty significant negative impacts downstream, or perhaps moderate their operations so that the impacts are not as bad as they've been in the past. So what we're looking at here, it's kind of complex, but the red bar is how much water was held back in China's large dams in cubic kilometers. So you can see in 2017, there was a large amount held back. 2018, there was a large amount held back. And this was over the course of just the wet season. So one reason why the 2024 bar is a little bit lower than the 2017, 2018, 2020 bar has to do with, one, the Nuojadu Dam filled up not during the wet season. It did some of it during the dry season. And also the dams started at a higher level than normal. But when we compare the portion of flow of what we estimate as natural flow that would have flowed to the Chengsen gauge, it's the closest gauge downstream in Thailand, what portion of natural flow is held back in China's dams over the course of that wet season, we start to see some interesting finds. So years 2019, 2020, 2021, there were high portions of natural flow, what we estimate as natural flow, held back, around 30% or more. After this, we're observing lower portions being restricted, or lower portions of natural flow being reduced as a result of these dams. 2022, 15%. 2024, even with all that rain, 18%. Is this a better outcome? Is there a lower number that's desirable? Alan, what's your interpretation of what we see here?
Well, as you said, there's a lot of information on this one plot. A couple of things to add to what you just said is it's not only is what percentage is being held back, but when is it being held back? And we've noticed that this goes back to a shift in the climatology. I mean, climate change is very real, and global warming is real. And we're seeing a melting of the snowpack in the upper basin earlier in the year. Normally, it'd be melting in June, July, with a little bit of melting in May. Now it's melting in April and May and June. So all that melting of the snowpack is what actually allowed the Najadu Dam to hold back water in times when the snowpack would not have been released and flowed down to the reservoir. So these are facts that need to be taken into account. So this is actually beneficial that China's taking that water during the end of the dry season and holding it back, allowing the flooded forest and the dry season to have its pronounced drying out, and allowing the roots of the trees to breathe and for new vegetation growth in the flooded forest to get established. This is wonderful. And then we're hoping that China can continue in this positive arena, using the changes in climatology to effectively manage the dam to maintain the integrity and the ecology of the river. So we're seeing this is data that can be used in very actionable and positive results, so that we're getting a better outcome of how water is effectively managed, both for electricity and for the ecology of the river basin.
I want to point out 2019, this is a really negative example of dam operations, probably the worst that we've seen. And in fact, Alan, this is the story that your team told, the story that got us all into this, the story of 2019, when there was a severe drought during the wet season. That's the low point of that blue bar, the blue line that you see here. Natural flow is very low, yet dams restricted the largest amount of natural flow seen up until that point. And then in 2020, it got worse again. 2019 is an example of what not to do for sure. Now, what should be done is perhaps that the downstream countries, the MRC, can work to think of a target. What is the targeted reduced flow restriction? What is ideal? What is realistic? Obviously, zero is not realistic and probably not possible. But 10%, 12%, a better outcome than, say, 36% for sure. We'll come back to this, and hopefully some of you that are watching will have some questions on this and comments and ideas as well. But moving forward, we're going to see how these dam operations, not just in China, but throughout the rest of the basin, impacted flow. I think here's something interesting. And Regan, who really runs the back end and the data production for much of the Mekong Dam Monitor, developed this map today, showing kind of how a bit out of whack flow was for the entirety of the 2024 wet season. And what stands out to me the most on this map is the portion of flow coming from Northeast Thailand was so much lower than other parts of the basin. Compared to a long-term baseline, natural flow would have been close to normal wet season flow in 2024. Dam restrictions were somewhat large. They brought that natural flow down a bit to Stung Treng in Cambodia. But other things were happening. And it seems that if you look at some of the numbers here, before dams were built, if we group this together, above Changsan and Changsan Vientiane, you get about 30% of flow contribution during the wet season. Here now it's 40%, right? China and above Vientiane. And then from the lower portion, Nakhon Phanom and Pak Se, if we add these together, Pak Se to Stung Treng, it's about 40%. yet here only 30% contributed between those two subbasins. So if we think back to Allen's wetness maps, we saw a lot of wetness, a lot of dryness, the red color in Northeast Thailand. Northeast Thailand was extremely dry compared to a normal baseline. And again, maybe something is happening with the climatology. I'm going to keep moving and run us through some of the dam impacts. Again, we've shown these charts before, but to interpret them, the blue line is historical norm. This is how the river flowed prior to the impacts of the largest dams. And the top of the blue bar is what was observed at the respective gauges. So we're looking at 3 gauges here, Changsan closest to China, Nakhon Phanom in the center of the system. And we add on with a time lag the water that would have flowed downstream if it was not restricted by dams upstream. And that's the red or other colored bars there. So you get a feel for how much dam impacts reduced natural flow or reduced the observed flow, and also how high flow would have been compared to a normal baseline. And for Changsan, you can see the effects of those August floods very obviously. The natural flow would have been much higher than normal during August. Dams actually brought it down to that normal peak. Thankfully, didn't take it down lower than the normal peak. And what's interesting to me is that Yagi really didn't show up on this on these charts. The September bar would have had Yagi's flow on it, but really both with or without dam impacts, flow in September was quite normal. If you tune your eye in most months to the beginning of the wet season, this is where we're seeing lower than normal flow. So under most conditions, either natural flow, the top of the bar, or what was observed, flow was below normal during those earlier wet season months. Moving downstream to Nakhon Phanom, you can begin to see the cumulative effects of those dams. In past years, we've seen the dam effects drop the blue bars way below the normal historical line. But in 2024 at Nakhon Phanom and at the Vientiane, you really didn't see this effect. So those gauges, by and large, throughout much of the wet season, saw a normal or higher than normal river system. You saw that at Vientiane in September and Nakhon Phanom in September too. Much of that is related to Typhoon Yagi. Moving downstream, though, we're starting to see the effects of the drier flow contributions from the downstream in Thailand and then in the 3S basin. I think this is particularly true for Stung Treng, where both in August and September, the effects of those major flood events upstream are somewhat muted. They don't translate as far downstream. And in many ways, this is a good thing because there was not a major flood event in and around Phnom Penh. Dam impacts reduced flow by about 12% in August. And that was the month where we saw the greatest reductions of flow. And I think what's interesting about August for both Paksay and Stung Treng, the impacts of both China's dams and the dams in central Laos, like the Nam Ton 2 and the Tin Hun Bun expansion dam, Nam Ton 1, they work together to have kind of an equal reduction of natural flow to those gauges. If we compare what happened in 2024 at the top of the basin, or at the top of the lower basin to the bottom, and 2023, we see some big differences. And again, it was these major events that drove flow higher in 2024 than it did in 2023. So in 2023 at Changsan, you saw flow levels under observed flow conditions that were much lower than the historical norm. Natural flow would have been a little bit closer, but even so, a lack of rain in 2023 would have had a much kind of lower river level compared to normal and a later peak than normal. But 2024 followed mostly a normal pattern. July was weak in terms of climatology. but the rest of the wet season was relatively normal. And the same can be said for the end of the wet season at Stung Treng. August, big floods in Thailand. But again, those didn't translate down to major effects to Stung Treng over the 2024 wet season. So let's think about how the climate of 2024 wet season and dam impacts affected the flood pulse. Alan, over to you for some flood pulse analysis.
Well, what we're seeing here is the middle of the map is the Tonle Sap Lake, and the green is what it would naturally be, historically would be flooded, and the blue is what is actually flooded in that particular month for that particular year. And you're seeing that we're moving into July. There's no data for June, and that's just the unfortunate realities of doing real-time research. Sometimes the data is not available when we'd like to have access to it. But you can see in July that you can see that normally there'd be much more extensive flooding. And the flood pulse coming into the Tonle Sap Lake, the reversal would be well established, but not so much this year. It was basically somewhat muted. August, we're seeing some flooding coming in, but it really took until September and October. And this goes back to what we were talking about earlier, a shift in the climatology. And it could be a natural variability. That's certainly a possibility. But we've seen this trend over the last 3 or 4 years, and why Brian and I are quite keen about doing a study to see if we can come up with some significant findings that this indeed is a shift, a climate shift in what's happening into the basin, particularly the lower basin. We're seeing flooding continuing into October and November, and then it's starting to basically the Tonle Sap Lake is starting to dry out. And the flood pulse is quite pronounced in Vietnam as well during the months of October and November, and still quite pronounced. As the Tonle Sap Lake actually serves as a reservoir to keep the delta flooded even as the dry season becomes more advanced. The reservoir, all the water held around the Tonle Sap Basin helps keep the delta flooded well into the early part of the following year, January and February. So this is something that we want to continue to study, and it goes back to Zeb's comments. Is 2024 was generally in the latter part of the season a fairly good year relative to the last few years. It's been a fairly normal year, and that can only be beneficial to the fisheries, the larvae coming in with the reversal. And if we could get more rain and more releases of natural flow early in the wet season, that could help bring in the flood, bring in the larvae, bring in the spawn, flooding the forest and bringing the vitality back to the Tonle Sap Lake. And then we start seeing an increase in fisheries and the large fish and a much healthier ecosystem. And so this is what we're seeing in this particular plot. Do you want to add to it, Brian?
Yeah, well, just to say that the pulse is always lagging behind. The green bar that we see in that chart is the norm. And by and large, the blue line is always behind the historical norm. So where the pulse would typically peak in September, it now peaks in October. It's been doing that for the last 4 years, I believe, that we've been watching this. And then the peak pulse just really didn't get within that normal bound that's in the previous map in September. And this is the second year in a row where you see just not being able to get into that normal bound, which only begs the question of the role of dams. That the dam impacts didn't appear to be huge during the 2024 wet season. However, they certainly were there. If they were more muted, could the Tonle Sap have had more of an expansion and hit its normal peak, at least during October? But Alan, run us through how the Tonle Sap expansion happened and reverse flow happened in 2024.
Well, you can see the reverse flow is the gray area on the top right. So the area in gray is Mekong water that's moving up the Tonle Sap River into the Tonle Sap Lake. And you can see in both 2023 and 24, there was a reversal. It's, as Brian just alluded, it's been below the long-term average, but there has been a reversal, but it's been delayed. Normally that reversal starts more in June, July timeframe, and now it's more in the July, August timeframe, and it's not as pronounced. And this goes back to the work that Zeb is doing as far as the fisheries. The whole ecology is built over hundreds and even thousands of years of when that reversal is supposed to happen, June and July. And their timing is important to bring in the spawn, to bring in the larvae. And if you're not getting a strong reversal, then you're not bringing in the vitality of the Mekong, the main stem into the Mekong, into the Tonle Sap Lake. And in 2022 is a really interesting example when the lake expanded, in fact, expanded far more. The blue line is how basically how high the lake expanded. And the expansion was not as pronounced in the natural in the gauge, which is the brown, as in the natural flow. And so this is showing that what happened, I'm trying to say simply, what's happening each year is unique. In 2022, there was almost no reversal. You see almost no gray area. Yet the Tonle Sap Lake rose to much higher levels than it had been in the previous years and the following years. Where did that water come from? It came from the basin. It came from the Cardamom Mountains. It came from Stung It came from the rivers that feed the Tonle Sap Lake around the basin itself. So it's important to realize that it's not just the Mekong waters that promote the expansion of the lake. The Mekong actually can serve as a dam to stop the water from being released from the Tonle Sap Basin, but it's the water and the rainfall around the basin that are driving the height and the extent of the lake's expansion.
Under certain conditions. And again, you're right that each season seems to be unique with what is driving that reverse flow and the flood pulse. In 2022, you can see that it hit the peak through those particular conditions around the local watershed of the Tonle Sap Basin. Whereas in 2023, 2024, just below peak, or the normal peak range. And to be sure, these results are much better than 2021, 2020, and 2019 before that, when the flood pulse and expansion really didn't get close to achieving a peak. Alan, let's take it into the more current era, into what we're seeing now, and we'll transition to a bit on the dry season. We'll wrap things up and go to our discussants and have a good Q&A with everyone tuning in. Take us through what we see here.
Okay, well, the top are basically wetness anomalies. So anything that's in shades of red, the darker shade of reds means drier than normal. The darker the red, the more extreme the dryness. And in contrast, you're seeing below to the south of the lake, you're seeing colors of blue. The darker the blue going towards purple are extreme wetness. So this is what we've been talking about throughout our presentation, that something has shifted. These are anomalies, variations from long-term 30-year averages from 1992 to current. So you're seeing in October 6th to 12th, late October and early November, and even right through December, you're seeing blue anomalies, pronounced blue anomalies in October and November. This is extreme wetness that's getting into the Tonle Sap Lake through the basin that supports it, not from the Mekong, but the basin around the Tonle Sap Lake itself. And you're seeing below, you're seeing the effects of these wetness anomalies. One of the things to note is that, and there's a concern that Brian and I had, that maybe our map is off because we saw much more extreme anomalies to the south of the lake. In other words, the flood pulse was much more pronounced to the south and much weaker to the north of the lake. And this goes back to looking at our anomalies. North of the lake, it was dry. So the flood pulse from the north, from the lakes that feed the lake from the north, the Stung and other rivers, just did not have the water to expand the flood around the lake. Whereas to the south, just the opposite was happening. There was extreme amount of wetness and around Phuket and other cities. I'm in Phuket right now, but also Battambang, they had extreme flooding and extreme expansion of the flood posts late in the season, abnormally late in the season. So this is again where we want to see if climate change is having an impact on the health and the vitality and the timing of when the rains occur. So this is a map that we just generated yesterday. The temperature is, you can see the darker the orange, the more extreme the temperature anomalies to the left. And you can see that the most extreme anomalies are in northern Laos, but going all the way up into the upper basin and all the way down with, in a little bit even into the delta, and covering most of northeast Thailand. Finally, in northeast Thailand, they got some good rains and they got some good wetness. But it was dry throughout much of the year, and its contribution to the Mekong flow was much more muted as a result. But look what's going on. There should be a snowpack up there, and it should be accumulating and then melting in the late spring, but that's not. Temperatures are warm enough that it's rainfall and it's flowing because it's water. It's not acute snowpack, and it's flowing into the Mekong late in the season. And this is when you could fill reservoirs without such an ecological impact. You could fill reservoirs now and basically have less of a need to fill them in the early part of the wet season, fill them when the water is most prevalent and when the ecology would be less impacted. It would, as far as the reversal, allow the reversal to take place when it normally does.
Right, and we're instead of seeing the reservoirs filling now with that excess wetness, we're actually seeing them release. So Norjadu and Shaoan started their regular releases that we typically see during the early dry season over the last 2 weeks. And this is translating into higher river levels downstream now. So the mountains or the peaks of water that typically appear during the dry season as a result of hydropower dam releases are starting to appear. That's a 1.5 meter change around the Jinghong gauge. It translated to roughly about that much once, and then again just over the last 2 weeks downstream in Changsan. What's interesting to us is that we provide alerts when these sudden pulses of water come out of the Jinghong Dam from either the Jinghong Dam or upstream dams. And when the river raises or reduces its level by 50 centimeters or more, the little kind of steps that you see here, interestingly, are just below 50 centimeters for a 24-hour period. Therefore, we don't release alerts. We're thinking of a way to inform the downstream that these pulses of water are coming because it's possible those that are operating the dams are working within the threshold of what is being warned and wanting to avoid the negative attention that comes with that. But at the same time, the downstream deserves to be warned that these mountains of pulses of water are coming downstream because they have an effect. And this gets us to what likely will happen over the course of the coming dry season months. The reservoirs are high, particularly in China. They're as high as they were in 2018. So a 2018 observation of the Changsan gauge, how did water flow at Changsan during 2018 might be a good proxy for 2025 dry season. And the news is not good. We see some major peaks here on the right with the Changsan blue line, the darker blue line. We see that is raising the river to much higher levels over the course of the dry season. And in fact, the 2018 flows redefine the maximum for the Changsan gauge. That's not a good outcome. During the dry season, river levels should be low. There should be a natural valley to the river's natural flow system so that people can get out into the river, collect things from the river that they typically collect during the dry season. Fisheries, wetlands are all tuned to this natural dryness during the dry season. Unfortunately, that's not what the 2025 dry season is going to look like. It's going to look like what you see in the 2018 line. varied, but high. And to think about what the particular monthly effects could be, we've seen in the past at Changsan where China's dam releases can triple flow. That's what you see in March of 2022. You see a very kind of varied flow regime rather than a natural valley effect that we see in the pre-dam mean line, the light blue line there. Farther downstream in Stungtrang, dams in China and the rest of the basin together can double flow. So March 2022 is basically a doubling of flow to Stungtrang. People who rely on low river levels during the dry season need to adjust for higher river levels and sudden changes and variability during this particular dry season. We're going to be watching, we're going to be warning. Things to remember is that one, birds tend to lay their nests along the riverside during the dry season. Local people watch this. Unfortunately, I think that the bird nests are going to be in trouble this year. And if a light can be shined on this particular practice of these behavior of the bird species, it's possible then to message the upstream, hey, don't release right now. Give the species of the Mekong a chance. Give the people of the Mekong downstream a chance to do what they normally do during the dry season. And with better messaging, better dry season flow regimes can be possible. So perhaps 2025 could be an example for that. I'm going to end my presentation now. We're going to shift it back to Courtney for some discussion. Let's do about 5-6 minutes from Locke, and then we'll turn it over to our audience for some Q&A. Thank you, everyone, for your patience to get through a lot. We have a lot of content, a lot of analysis to share with you, and looking forward to engaging with you in the Q&A.
Thanks, Brian, and thanks, Ellen, for that. It's definitely a lot to absorb, but I do see we're getting some good questions coming in. So I would encourage everyone in the audience to continue sharing those questions via the Q&A button at the bottom so that we can get to some of those when we move into the discussion. But in the meantime, in interim, I do want to turn things over to Sreelak Mick, who's joining us as the Technical Climate Resilience Coordinator for the Mekong Regional Water Governance Program at Oxfam. And Sreelak Mick is on the ground in Cambodia. She can share some perspectives about what she saw with her work and what the Oxfam team sees with their work throughout this past wet season in terms of extreme weather events, in terms of the health of the system. So Sreelak, over to you.
Yeah, thank you, Courtney. As you already introduced me, so I'm not introduced again. So during that time I have heard from Ellen as well to update on the changing in climate and how might we. I really like the word of you saying actionable. So in Cambodia during the Typhoon Yagi, there is no significant impact in our country, but they also have the dissemination to prepare for that flooding, which is predicted to be happen. And for the first, it's going to be only 2 provinces. And after it expands to 5 provinces, have to keep an eye on the monitoring on the water data sharing and also water monitoring station to be able to alert in time to the people who live along the river and the people who are vulnerable to that. But back to the experience that we get from Yangtze in northern Thailand, they have the best practice that the community-based early warning system, that they use the line to share those kind of information, and they share the flooding 3 days in advance. So the people can prepare for this flooding, and also local authority, which is guiding before, during, and after the flood, so they can evacuate the people with disability, and also they can use the tractor as you see on the news. And this is the good practice that how can we use those kind of scientific data to translate into community language and community mechanism to make it actionable. So in terms of early warning system in Cambodia, they have 1294, which is coverage in Cambodia and under managed by National Committee for Disaster Management, and it works closely with Ministry of Water Resources. So one thing I want to emphasize this is the flow change plus climate change, as we already know. And the role of early warning system is very important. And when we need to think first about the early warning system is who is the most vulnerable in those chains, who is the most vulnerable when it comes to alert. So, for example, in Cambodia, in the northern, they have indigenous people, and some of them they could not understand. They have the limit literacy on Khmer, and also they first had to understand the warning information and cannot make this information into action. So the local authority is playing an important role to inform the people. And we heard from the community as well that they want to know about the transboundary early warning system, that they can inform their action in advance before, because they are live close to the upstream. And it makes us to see when it comes to transboundary is what happened in the upstream and how it impact into downstream. And is the current early warning system is actionable by a referent community. And which is I want to emphasize about when we design the platform and also when we disseminate the early warning system, we need to make sure it is translated to the people who need to take action in advance. For example, is the local authority that is the front line to respond to this disaster management. And we can see the good example in Pakha that they have the line group and they also have the flood preparedness in place and who's gonna do what. So when it comes to be flood, even though it is severe, but it can be decrease the loss and damage. And the last point I want to mention is about the same early warning system. It's need to start from the human-centric design, and we need to learn from the community how they cope with that change, and also the history impact, as well as we saw the map that have been shown by Brian, and also explanation by Alan, and how we make those scientific to combine with community knowledge and make the early action to the community that they can identify the challenge and they can find a solution which address the need of them. And yes, again, community-based early warning system is the good choice for the community to be actionable, reachable, and trust. That's all from my side. And if you have any question, you can ask. Thank you.
Thank you so much. And I think we will get some questions on this, and I think we may be able to start with one question that does touch on sort of the challenges of managing extreme weather events. So I'm going to go ahead and move right into the Q&A. So please, if you have questions, do keep them coming. But I'll start out with one that was asked early on in the presentation, but I think might build nicely in what you were just saying, Srilak, which is, looking at the future of the dam, looking at the future of the system, we see, in addition to the dams that already exist and are operating and impacting the flow of water through the system, there's a lot more planned in the future. And as we also saw from not only this wet season, but also others, we've been seeing sort of increasing instances of major and extreme weather events, and increasing vulnerability from communities to these weather events because of where they live and how the flooding is impacting. So, there was a protest about 10 days ago in northern Thailand along the Mekong River in the Chiang Rai Chiang Khong area, related to the Pak Bang Dam Reservoir, including, concerns that particular reservoir might impact future flooding events like we saw in Thailand. Obviously, that's one of many dams planned, not just in Thailand, Laos, Cambodia, but across the whole basin. So I guess I'll first direct this to Brian and Alan, but do you guys see that there is analysis being done on how some of these new infrastructure projects might play into these types of flood events, specifically speaking to Pak Bang if you can, but potentially also speaking more broadly. And certainly, Srilak, if you have thoughts on that as well, please feel free to chime in.
So with the Pak Bang Dam, and I think the protests and the calls to action that happened in and around Chiang Khong and Chiang Rai province last weekend really deserve a webinar of their own, and to get the message out to the world of what the concerns are there. And Courtney, let's come back to that. Let's do this next year and invite those involved to speak about their needs. I think the major worry there is backflow effect as that reservoir fills. It will have a transboundary effect upstream of the dam, up into the Golden Triangle, up into Thailand. And modeling can demonstrate what that effect will be, but ultimately it won't be known, unfortunately, until the dam is built. And then another concern, from what I understand, is how that dam will operate during an extreme flood event like Yagi or the August floods. Will it work to exacerbate the floods, so much so that the floods can't clear and it creates a longer flood time? Or can they work to clear the flood more quickly? And as you add more dams into a system, in and around an affected community, let's think about Luang Prabang now in Laos, which is essentially, it's pinned in on all sides by many dams on the mainstream, on tributaries as well. The Nam U has a cascade of dams on it. The Khan has 2 large dams on it. Luang Prabang is again effectively surrounded by dams, and in order to prevent a flood from happening at Luang Prabang, all of those dam operators need to coordinate their gradual releases and not have sudden releases during a major event, so that there's not this kind of sandwich effect of water coming in all at once in and around Luang Prabang. The long and short of it is that dams and more dams introduce more and more complexity, require much more cooperation and coordination during extreme weather events like Yagi and those that we saw this year. And I'm just not sure that the governments that help and drive the coordination forward are ready to meet that. Many more resources need to be put into governance now that there's much more complexity added by these dams and more vulnerability created to these, and exposure created to these communities downstream.
Thanks, Brian. Alan, Sherlock, did either of you want to chime in?
I can chime in for a moment. We had, where I live in Asheville, North Carolina, we had severe flooding from Typhoon or Hurricane Helene, and caused huge devastation, very similar to what happened in Chiang Rai. And one of the things that we learned is that proper action mitigation strategies, early warning system, and coordination among the dam operators can actually be a huge benefit. If you know, as we knew with Yagi, days and even a week in advance that the storm was coming, reservoirs can be dropped down to dead storage. And then they can start to fill during the peak of the flood, holding the peak back and mitigating some of the severe flooding that would otherwise occur downstream. So coordinated, as Brian said, and as we have learned, that reservoirs can be a huge benefit during flooding if they're used effectively to hold back the peak of the flood. But this is a coordinated effort, planning, organization, and action that is done in advance to protect the people from the severity of the flood.
And I just want to underscore that.
Promising.
But I want to underscore that floods also have a very positive effect in the Mekong. And I think our work has done a lot to promote and show what the positive benefits are. So a culture needs to emerge where both there's a need for greater coordination among these extreme events, which will happen more frequently, yet at the same time, not reduce the positive benefits of the floods and what the waters and seasonal inundation bring in terms of positive fish catch, more agricultural production. So this is a balancing act that the lower countries are going to have to achieve. And then also communicate their needs upstream to China, where those big dams can be used for good, is what we've said here tonight, and for extremely bad outcomes.
All right, thank you. And sticking with sort of the theme of development challenges and how this might be impacted by extreme events and other changes with the system, we had a question from Virak Rowan in Cambodia. Do you think land reclamation activities along rivers in Phnom Penh could pose environmental risks to the health of the rivers and the Tonle Sap Lake and some of these broader flood pulse systems that we see? And do you see opportunities or better examples of what urbanization of cities along rivers could look like?
Let's have Zeb or Lak chime in on that because they've spent a lot of time in Phnom Penh and seen this kind of development, and perhaps thought about how that development impacts the ecology and the fisheries of Cambodia. Thoughts?
So to me, I think I might not answer the right answer because I have been here. I was born in Phnom Penh, and we can see they develop a lot in along the Tonle Sap. And but the thing is important is we need to look at the sustainable management and the governance of the land governance in Cambodia, and also the historical of the ecological river, and also where is the habitat of the people who used to live, and where is the site that should be developed, and where is the water can release into back to the river. And the thing is the water quality and also the flow levels is important dimension of the ecosystem, and the people in the urban area might not be affected a lot during the flood, as we already have that early warning system, and also they have the mechanism take in place in local authority take in charge of to inform to the people, but through back that to the countryside and the people who doesn't have the knowledge to take that kind of action. So for sustainable is we need to see a lot of dimension during the development as well. And the risk assessment and risk management is playing an important role in the urban planning. Yeah.
Mhm.
Or maybe Alan can put something more. Thank you.
I think you explained it very well. There's a balancing act between urban development, which is naturally going to be occurring, and smart development, and realizing the cost benefit of some of these expansion and dredging of river and taking the sand out and building new land, and how sustainable and what are the impacts is where we need to get a better understanding.
Zeb, thoughts about land use around the river and the lake?
I would just say that the connection between the Mekong River and the Tonle Sap Lake and the floodplains in southern Cambodia and the Delta is very important. Some people might not realize one of the largest fisheries in the whole basin is just outside of Phnom Penh, and it's based on migratory fish. So it's based on the movement of fish out of the Tonle Sap and into the Mekong. So any development that's happening in the Phnom Penh area, certainly in terms of from a livelihoods and fisheries perspective, it would be a good idea to take into account that important connection and the importance of flow and connection to a fishery that historically, is yielding 10,000 or more tons of fish every year. So, and it's incredible. I was there 3 days ago. You can still see thousands of people fishing out on the river and just net after net coming in with, one net was 500 kilos of fish. So it's pretty incredible. Still happening just outside of Phnom Penh.
One observation that I've been thinking about, and Chris Hackney, who we've invited to our webinars before from the UK, he studies sand mining and sediment removal particularly from the area around Phnom Penh. And he's got a new paper out showing that riverbed incision or a dropping riverbed as a result of all the sand mining is making it harder for the reversal to happen. And at the same time, that sand that's removed is being used for the land reclamation work there in and around Phnom Penh. So more to be said on that, and I think he's learning more with his work. It would be great to have a kind of a budget, like the WWF promotes a sediment removal budget that is sustainable to a degree, but doesn't affect the reversal or these ecological processes so much so that it requires more energy and more water to have the flood pulse do its work. An observation that I made watching Yagi flow through the system was that the new Diamond Island complex flooded in Phnom Penh. And at the same time, Phnom Penh didn't get close to flood level. So that land reclamation was built below flood level. and businesses suffered. People suffered as a result of it. Is it a good policy to build below flood level? Not in the Mekong. And I think those who invested in that space probably learned a lesson. But it's going to be seen over and over again because that's basically a permanent structure now. Courtney, back to you.
Thanks. I know we're coming towards the end of the hour, so we'll probably go a few minutes past to try and get through some of these questions. I'm going to ask one next question. I'm going to give Zeb the first chance to chime in on it, simply because I know Zeb has to head off at the half hour. So we had a question from Jerry Flynn regarding the southern Cambodian fisheries and wetlands, particularly around Takeo. Are those areas likely to be affected by the Funan-Teko Canal if that project were to move ahead as planned? And, what sort of impacts might we expect to those fisheries and ecosystems if we start seeing that project moving along in terms of construction?
Yeah, that's a very good question. And it's not one that's been well studied. It deserves much more study. Historically, there's a lot of movement and connection between the fisheries in southern Cambodia and, downstream of Phnom Penh and the Vietnam Delta. And so I think, whatever impacts there may be, I mean, certainly it's worthy of more in-depth study. That's kind of, in terms of fisheries, we have a much better understanding of what's happening in the Tonle Sap and in the upper Cambodian Mekong than we do downstream of Phnom Penh. But whatever impacts there are very likely to be felt both in Cambodia and in Vietnam. It's not going to be an impact, uniquely to Vietnam or uniquely to Cambodia. The rivers shared, the fisheries are shared. We see a lot of connection in that area. And I think that definitely deserves a closer look.
Brian, did you want to chime in on anything about the canal? Or
I just agree with what Zeb was saying. Much more studies need to be done. Nothing has come forward in terms of what has been produced in terms of research around the Funan-Teko Canal. And it's always concerned me that what actually has been done. Feasibility studies have been talked about. Excuse me. Other studies apparently are being done, but not much information has been provided. And it seems that the canal, given that it moves through an active floodplain, is going to create some wetter zones and some drier zones unless there's a kind of mitigation that's put in if the canal is built after all.
Thank you for that. So changing tacks a little bit, we have a question about some of the projected and expected dry season impacts that we talked about today. Has this information about the 2025 expected dry season been communicated to China? If so, could you share a little bit about how, or do you have any suggestions on how to engage with Chinese actors, particularly dam operators, about the flow releases?
Well, we hope that there are Chinese stakeholders and scientists and concerned parties tuning into this, that they tune into the video and can communicate this message upward into the decision pipeline. I mean, really, this is something that's known in China because the Chinese reservoirs are high and they're higher than normal, higher than ever before. So then their impact will be higher than ever before, potentially. That should be understood. One of the issues, though, is that in the PRC, the discourse is dams are used in the dry season for raising the river level downstream to relieve drought, to help the Mekong Delta. And there's a sense that there's a positive benefit to this. So there's absolutely no evidence out there that shows that these large dam releases have any positive impacts whatsoever. So I think it's important for downstream stakeholders and for the Mekong River Commission to communicate the needs and to say, hey, there's suffering here when these sudden pulses of water come downstream. Bird conservation is important to us. Why? And here's what needs to happen to protect these bird species. Flooded forest protection is important to us. This is where the giant stingray lives, where the giant catfish has been caught, etc. These messages need to move upward, upstream, so that the ecological benefits of a dry and low dry season are better understood.
To interject and to add to what Brian said, I would like to add that I don't know of any direct formal mechanism of communication. I think it's a wonderful question and have a forum for dialogue. The second point is, as we see that these reservoirs are at basically full capacity, it's possible that the Chinese, and realizing that the dry season tends to extend out into May and even early June, which is which is not the climatological norm. If they could hold water back in the reservoirs and start releasing it in May and June, not so much in February, March, and April, then they could still produce electricity and get the returns from the reservoirs, but they could maintain the integrity of the dry season, the low flow, and add to the additional flow from the lack of water in the early part of the wet season by releasing during that time. So gaining the benefit of electricity, when instead of filling reservoirs, they could actually be draining reservoirs during the time when the river likes to rise traditionally, and promoting the reversal and the Tonle Sap in a more timely fashion, such as June and July.
Yeah. So one way to think about it is for those technical people out there, to shift the operations curve later, like 2 months. And explore what the benefits could be.
All right, thanks. I know we're over time at this point. We do still have a few questions coming in from folks in the audience. So I'll take one more question here, which I think is an interesting sort of thought question to end on, which is that there was the point made by Andy Stone that there's some dissonance between talking about seasonal flood pulse and the fact that if many of the proposed and planned dams move forward, that the river system is going to be a series of reservoirs rather than a free-flowing river. And, we're talking a lot today and in the analysis that our team and others are doing about the number of cubic meters per second that is flowing. But that number means something very different in a shallow, narrow river than it does in sort of a river reservoir in terms of ecological, hydrological terms, or even river morphology. So can you talk a little bit about whether the focus on flow and volume per second is useful, or if there are other measures that might be needed to help track how this will impact the ecological aspects of the river?
I think one revealing study that's been done is what Ian Baird did over the course of last dry season, by taking some of the observations that have been seen via satellite and also the hydrological gauges and sharing them with local communities. We want to emulate that practice and have a deeper conversation with communities about how they see the river changing, and to track what's being lost and what is changing, how wetlands are changing, how flooded forests are changing, what species are disappearing, and tying that to the data, and then taking that forward into more forward-looking solutions, because those losses are not necessarily being communicated to decision makers, and they're not yet cataloged really. Some of that is because of a focus on all the gauge data and the flow data, et cetera. So much more work needs to be done. We like to see a type of a virtuous circle that comes from this, where data is being produced, it's taken to the field, to the communities, communicated, feedback is then created, and more can be done with this. So in many ways, we're all just getting started, and there's a lot more work to be done.
All right, thank you everyone for joining. As I said, we've had a lot of really good comments coming in as well as questions. So I will note that those we didn't get to discuss today will be shared with those of us on the panel. So there might be some follow-ups that can happen offline. But thank you everyone for joining this discussion. As we said, this is one in a series of discussions that we hope to continue having into the future, both with our seasonal updates and our Mekong Water Data Hours, highlighting studies that have been done. So we look forward to seeing many of you continue to engage in future events. But thank you for joining us. Thank you for staying a little bit over time, and we wish you a wonderful rest of the night if you're in the United States, and a wonderful rest of the day if you're calling in from Southeast Asia.